All right, so hopefully everybody did a good job with 12.1 and our little review of linear equations. So hopefully it was a review. Hopefully we've done this at some point in time. So now what we want to move on to is kind of the real data. So in math, a lot of times we talk about like real world problems and stuff like that. And so we give you this artificial problem that sort of works out perfectly. In reality, that's not really the way math works, and you probably knew that already. But what we're getting ready to do is the way math works. So what happens is someone collects data and they have to represent it some way. So in this case, since we're talking about ordered pairs, the way we're going to be representing our data is what's called a scatter plot. And so what it is just a collection of all these ordered pairs. But in this case, since it's real data, there's no hope that it's going to look like it did in the last example where it makes a perfect line. So that's kind of where we're going with this. We want to be able to actually figure out a line that models this real world data. So in this case, like here's an example of home prices, based on the size, which we're going to let be the x variable in this case. So our input is the square footage, and the output is going to be the selling price in thousands. So in this case, this first point tells us we've got a house that has 2,521 square feet, and it's worth $400,000. So just to kind of shorten it up, we've cut off the last zeros just to make it easy to graph and stuff like that. And so if we look, we can kind of find where each of these would actually be plotted. So 2521 would be this guy right here. And then we've got 2,555, $426. So that's going to be that point. 2735, 428. So that's going to be that point. 2846, 435. That's going to be that point. 3,028 and 469, so that's going to be that point. 3,049 and 475 is going to be that point. 3,198 is going to be 488, so it's going to be that one. And then we have another 3,198, which is a little bit less money in this case. So basically, it's just plotting a bunch of ordered pairs and stuff like that. So we'll get into the fancier stuff later. But based on what we've talked about in the last situation, what can we say about these points? And this is going to be important. This is some of the stuff that we want to work on. So if we notice as we go right to left, or left to right, sorry, what can we say about our input values? Are they getting bigger or are they getting smaller? So our input values are getting bigger. And if our input values are getting bigger, what's that say about the slope? Right, so this looks like it's going in a positive direction. And it might be hard to see at the moment, but in this case, this actually is kind of looks like a linear equation. So it kind of looks linear. So again, we haven't worked with these too much yet, so you can kind of take my word for it that this kind of looks linear in shape and stuff like that. So these are the things you want to be able to point out, like what's the slope look like? We're also going to talk about strong or weak. This one's kind of hard to tell, like, because the points aren't super, super close together. So I wouldn't say it's strong, but I wouldn't say it's weak either. So it's kind of like a middle range. So, I mean, you'll see ones later where it's really, really weak and really, really strong. So in this case, it's probably not too bad. It's still probably okay. All right, so in this case, what we're talking about is association, which is what we were actually talking about above. So there's a bunch of different ways that we want to think about these scatter plots when we're talking about them. So there's going to be the direction, which is going to be either positive or negative, pretty much. So two variables have a positive direction if larger values of the input are linked with larger values of the output. So just like I said above, are the output variables getting bigger as we go left to right? So that's basically what this is saying. So the outputs getting bigger as we go left to right. And we're going to have a negative direction if the smaller values of the input variable are linked with the larger values of the output variable, or another way of saying it is the output gets smaller as we go left to right. So in this case, we're really only looking for kind of positive and negative. And then what we're looking for is the strength of the relationship. So two variables have a strong relationship if the grouping of the points are close together and kind of resemble a line. They're weak if, when you're looking at the graph, the points are further apart, but you can still tell that it resembles a line. And then finally, the last one is like you basically have no clue. Like it just looks like a bunch of points, and there's really no obvious shape that you can draw that goes along with those points. All right, so with that in mind, at this point, I'd have you guys yell these out just to kind of figure out like which one is which. So, but what we want to do is we want to talk about these in terms of whether they're a positive, negative, or whether they have kind of no association whatsoever. So this one I would definitely say is positive, because as we go left to right, notice the output values are getting bigger and bigger. And in this case, I'd say it's a pretty strong, what do I call it? Strong relationship, just because all the points are pretty close together. So this is positive, strong. So this one's going to be negative because notice as we go from left to right, our values are getting smaller and smaller and smaller. So this is going to be negative. And again, I'd say this is strong because those dots are all pretty close together and I can almost visualize what a line would look like. So this one is kind of all over the place. So technically you probably could think it's positive, but again, since this one's not strong at all, so this one would be the no relationship whatsoever. So in this case, I can't really tell whether it's a line or whatever shape it would actually be. So this is just going to be bad data. Sometimes that happens, sometimes you just can't make a relationship. So it's nothing wrong, like it's nothing that you did wrong collecting the data. It's just that the data doesn't go together and it doesn't make a nice linear relationship like what we're looking for. So don't think that you did something wrong if that happens. All right, so the last two. So again, this one looks like it's positive. And again, I can kind of tell that it's a line, but these points are definitely further apart. So I would say that this is a weak positive. And the last one over here is definitely negative. And again, I can sort of tell that it looks like a line, but again, this is going to be a weak negative for me. All right, is that okay with everybody being able to identify all the different parts of a scatter plot? All right, perfect. So the last thing we want to talk about is what's calculating what's called the correlation coefficient. And so this is actually going to help us to determine whether a relationship is strong or weak. Because the problem is, like, when we look at graphs, like, it's too subjective, because there could be people that look at this graph and go, well, I think that's pretty strong, actually. And I might think this is weak or something, so because it's somebody's opinion. So we need to be able to actually justify this with some math. So that's what we want to do here is find what's called the R value or the correlation coefficient of our scatter plot. And then from there, we can actually tell based on the number whether it's going to be a strong or a weak relationship and stuff like that. So I'll get more into what the number actually means in a second. But let's use this same house pricing data and go through and actually calculate it. So at this point, I've kind of, we got to do a little bit of math first because what we have to do is actually find the sample mean and sample standard deviation of the X data. And then I want to do the same thing for the Y data. And then I'm going to plot those guys in the points. So in we already know. And so, because in this case, we can just count. So we did 1, 2, 3, 4, 5, 6, 7, 8. So we used 8 data points to collect our data. So we know N, and N's always going to match, because if it doesn't match, then we wouldn't be able to make ordered pairs. So kind of keep that in mind. Our N's are always going to be the same. So now what we need to do is go through and actually find the sample means and the sample standard deviation. So this is where we're going to use our 1var stats in our calculator, if you've forgotten how to do it. So we'll end up putting all of this data from the square footage in list 1, calculate the 1var stats, then we'll put all the data from list 2, or from the selling price in list 2, and then calculate the 1var stats. So I forgot to do this ahead of time, so let me write this down real quick so I can actually, so I don't have to keep flipping back and forth. All right, so let's see. Actually, let me pause this real quick.